system, there are no planets between the size of the Earth and the next largest planet, that of Uranus and Neptune.
Astronomers call these mysterious planets super-Earths.
Super-Earths are about 3 to 5 times the mass of the Earth, and there's nothing like that here. We don't know what they're like. It's an entirely alien sort of planet.
In just the last few years, astronomers have begun to imagine the conditions on this new class of planet, and they've come to a startling conclusion. Super-Earths could be super-habitable.
There are probably planets out there that are even more hospitable for life. Planets that have even more chemicals necessary to create the organic materials that create life, conditions that make it more likely to get life off the ground.
Imagine a rocky planet, twice the size of the Earth. Dramatic volcanism on the surface betrays a vast heart of fire that beats within its core.
We expect that a heavier Earth will be more geologically active, that the increased amount of geothermal heat within the super-Earth will lead to stronger motions of the magma underneath the crust.
Belching volcanoes dot the surface of this super-Earth. Their gases feed a super-thick atmosphere and help to regulate a super-stable climate.
Many times, life on Earth was nearly extinguished. For example, once upon a time, the Earth was snowball Earth, completely covered in ice. Maybe in these other planets, there are Earths in which snowball Earth never happened, that the climate was always stable and temperate.
The grip of gravity is 3 times stronger here than we're used to. It pulls mountain ranges down to 1/3 the height they'd be on Earth. Gravity also flattens the ocean bed, making shallower seas filled with volcanic island chains. And the nutrient-rich waters that surround these archipelagos provide the perfect conditions for life.
In these other planets, perhaps they have conditions which would make DNA get off the ground much earlier and flourish much more quickly.
Finally, our super-Earth may be protected by a super-magnetosphere.
The magnetic field strength is a condition both of the mass of the planet as well as its rotation speed. And so it is quite likely that a planet that is a couple of times bigger than the Earth's would be able to develop a stronger magnetic field, may shield the planet even better than our magnetic field shields us.
Having a stronger magnetosphere would be a distinct advantage for life on a super-Earth surrounding the Milky Way's most plentiful kind of star, the M dwarf, or red dwarf star. Red dwarf habitable zones are much closer in than the Earth is to the Sun because their host star is so dim.
It's as if you took the terrestrial planets in our own solar system and zapped it with a shrink ray gun and shrunk them down to orbital periods that are less than about 30 days, meaning that they're very close to their stars.
Some astronomers believe these planets are at risk from solar activity, such as deadly flares. But a super-Earth with a super-protective magnetosphere may well resist these deadly rays, allowing life to flourish under a psychedelic sky full of swirling auroras.
If one was standing on a super-Earth, we would see the aurorae come down to lower latitudes. You might get different colors. If I had the opportunity to travel to one of these exoplanets, I would snap that up pretty quickly.
Most intriguing of all, if life does exist on a red dwarf super-Earth, it could be home to the longest-lived civilizations in the entire universe.
The advantage of the M dwarfs is that they last for much longer. And if you had a super-Earth then, keeping a strong magnetic field, going for billions and billions of years, especially now around a red dwarf that is going to exist for billions and billions of years. You might be in that perfect system where life can exist and evolve into even more complex beings than us.
we're getting so close. Our local neighborhood of stars teems with red dwarfs, bursting with the potential for advanced life. But there are also cosmic killers out there, lurking in our galaxy, primed to wipe out life on a regular basis. Is anywhere safe? The exoplanet revolution is in full swing. The Kepler Space Telescope has scanned our local neighborhood of stars for planets, and it's found them by the thousands.
For a long time, we didn't know if the other stars in our galaxy had planets. And for thousands of years, there was no way to answer that question. Finally, now with modern technology, we can do that. And to our surprise, we found they are extremely common.
From Kepler's small sample, astronomers believe there could be tens of billions of rocky, Earth-like planets throughout the Milky Way, where life may already be thriving. But how many of these countless worlds has held on to this life long enough for intelligence to evolve? The answer, surprisingly, may depend on a planet's galactic zip code.
The universe is not a happy, safe place. The universe wants to kill us. It's incredibly violent out there. There are solar flares and supernovae and black holes and colliding galaxies and all these really amazingly dangerous and violent events. It's actually kind of amazing that we're here at all.
In order to develop advanced, intelligent life, an exoplanet may have to avoid these cosmic killers for over 3 billion years.
If we look at the history of the Earth, the first thing that happens that's important is the origin of life, right away, very quickly. But then, nothing for a long time. You have nothing but microbes stomping on the Earth.
For the first 2.5 billion years, the Earth was ruled by single-celled goo. Multicellular life has only been around for 1 billion years. Fish for 500 million. Mammals for 200 million. And modern humans have only walked the Earth for the last 200,000 years. The lesson is clear. It takes a long time to cook up intelligent life. But most planets in the Milky Way don't have that kind of time. Astronomers believe that a planet's position within a galaxy may determine if it gets hit by global extinction events.
There's an idea of a habitable zone for a galaxy, and it's in analogy to the habitable zone around stars.
Stars too close to the galactic center are in the firing line from their violent neighbors, which frequently blast them with deadly high-energy radiation.
In the middle of a galaxy, we have a lot of bright stars and young stars and maybe even supernova going off. And so there's a very harsh radiation field. That's not good for life.
Fired up by the supermassive black hole that sits at the center of the Milky Way, this cosmic kill zone stretches out around 8,000 light years from the galactic center and extends out along the densely packed spiral arms. Any planets that exist within this zone are likely to have their surfaces regularly scrubbed clean of life. Fortunately for us, our home star, the Sun, sits in a relatively empty, quiet zone between two of the galaxy's spiral arms.
So there's this idea that there's a band in the middle of the galaxy that's the galactic habitable zone, where you don't have too many stars going off, you don't have too many supernovae, so it's quiet in that way. Those might be great places for complex life.
These green zones are like the suburbs of the Milky Way galaxy. They're sheltered from the worst of the galaxy's radiation. It's here that Earth-like worlds will have the luxury of long, uninterrupted periods for life to take hold and develop into more complex forms, and eventually, perhaps, intelligent life, like us.